Right, hi guys, welcome to your weekly introduction video. This week we're going to look at speed, distance and time. Now I know you're quite familiar with the concept of speed, distance and time, but on an IGCSE exam paper it can go from very, very easy to quite ridiculously difficult, these questions. So I'm going to kind of breeze through the easy stuff and then we're going to spend some time on some harder stuff, and in particular we're going to look at some paper 6 style questions that involve speed, distance and time. Okay, so starting off easy and then getting quite hard. So first of all, which of these formulas is correct? Now hopefully you remember that speed is equal to distance over time. So speed times time is equal to distance. And so time is equal to distance over speed. The only one that's there is correct is B. Okay, remember, you can remember all of these formulas by that little triangle. Speed equals distance over time. That should help you to know all of them. Okay. Now, so it starts off very, very easy. Sebastian covers 240 miles in 3 hours on a highway. Work out his average speed. Speed equals distance over time. Okay, his distance is 240 over 3. It's 80 miles per hour. Okay, make sure you use the right units. Now, Jess cycles to work at an average speed of 16 miles per hour for 45 minutes. What distance does she cover? Well, again, distance is equal to, check the right formula, speed times time. Okay, so speed is 16, but what is time? It's not 45 because you would be mixing hours with minutes. So we need to write 45 minutes as a decimal hour. Of course, 45 minutes is 3/4 of an hour, 0.75. So that would be 12. So what do we actually look for? Distance. It would be 12 miles. Okay, 12 miles. A mapping app suggests that the average speed on a busy road is 22 miles per hour. How long will it take to cover 5 miles on this road? Well, it should be straightforward. How long will it take means we're looking for time. Time is equal to speed over... no, it's not. It's distance over speed. Make sure you use the right formula. So it's going to be 5 over 22, which when you put into your calculator is 0.227 to 3 significant figures. And that is in hours. But it would be very weird for you to write an answer like that, 0.227 hours. We're going to try and convert that into minutes. So to convert that into minutes, I will times it by 60. So that's equal to 13.63 minutes. And again, it would be weird to write that. So we're going to convert that 0.63 into seconds. So we're going to get 13 minutes, and there are 60 seconds in a minute, so 0.63 times 60 equals 37.8 seconds. So I'm going to round that to the nearest number of seconds, 38 seconds. So 13 minutes and 38 seconds. So I expect you to be able to write say a decimal number of hours in hours, minutes and seconds. Okay, and you know, indeed, years, months and days, anything that they might ask you. Okay, let's skip past these. All right, have a go at these questions, stop your video and then I'll reveal the answers. Okay, here's the solutions. Okay, any problems, let me know. Okay, again, have a go. Here's the solutions. Let me know if you have any problems. Okay, and the last one, stop your video and have a go. Okay, here are the solutions. If you've got any of them wrong and you're not sure why, please just ask. Be happy to help. Okay, here's to spot the mistake. Well, I've already kind of cleared up what the mistake is here. They've used 18 minutes But then the answer is in kilometres per hour, but that doesn't make sense at all. Okay, so what you need to do is change 18 minutes into hours. So it's 18 as a fraction of 60 minutes. It's 18 divided by 60 is 0.3. And so you do distance over time, 27 kilometres divided by time 0.3 hours. It's 90 kilometres hour. That's the common mistake that got made. Okay, here's an exam style question, a basic exam style question. Have a go. Okay, here's the answer. Okay, now what I want to do is I just want to adjust this formula. It looks like I've gone the wrong way. I just want to adjust this formula. Okay, I no longer want to say that speed equals distance over time, although that is a perfectly true statement. I just want to adjust the formula to help you understand what happens when we get some trickier questions. What we really mean is average speed is equal to total distance divided by total time. Okay, and there's a distinction there because we use this formula. Well, maybe what if we're not going at the same speed for the entire journey? What if we're changing our speeds? We just want to know what the average speed is. So here is a question that, although it's a challenge, you should be able to do it. Okay, so I want to read the question carefully, stop the video and have a go, and use the formula average speed equals total distance over total time. Okay. Right, here's what we should do. Okay, so basically Carlos and Lewis are driving the same distance, okay? But one is doing it quick and one of them's doing it slower. Now the easy thing to make a mistake here would be think, well, if they're both driving the same distance, one doing it at 60 kilometres an hour and the other doing it at 40 kilometres an hour, then the average speed is 50, the average of 60 and 40. But that's not going to be the case, okay? Definitely not going to be the case. We need to use this formula. Average speed equals total distance divided by total time. We've got really limited information here. I'm going to say that the distance that Carlos drives is x. So the distance for Carlos is equal to x. And therefore the distance for Lewis is also equal to x because they both drive the same distance, okay? They're just doing half of the journey each. And we don't know time either, but what we do know is that speed equals distance over time. So I'm going to say Carlos drives at 60 kilometers an hour for a distance of x over the amount of time it takes, okay? And it's the same for Carlos. He drives 40 kilometers an hour for a distance of x over the time that he takes. I'll call that time too. Okay. So I can now write time in terms of x, where it's going to be x over 60, and time 2 is going to be x over 40. Now, average speed is equal to total distance divided by total time. But I can make an equation here. Total distance is 2x. Speed is equal to 2x. Divided by total time will be this add this. So that's x over 60 plus x over 40. Now this is why these questions get difficult, because we've now got some algebraic fractions to deal with, okay? So I'm just going to clear some space and go back in the video if you're not sure where this came from. It's just because I let x be the distance that one drives, that's half the distance, so combined distance is 2x, and these are the times added together for total time. So that is basically the application of this formula, total distance divided by total time. Now, I need to add the fractions in the denominator together, so I need a common denominator, so it's going to be 240. So 40x plus 60x over 240, okay? Which is going to be 2x over 100x over 240. Now, this means we've got something divided by a fraction, so we need to know the rules of fractions. So that's going to be 2x divided by 100x over 240 means times 240 over 100x. We flip and multiply. Okay? Notice now that the x's will cancel, and I'm going to get 480 divided by 100, so the answer is 48 kilometers per hour. Okay? So this is why this topic is going to get tricky. You're basically going to have to be using algebraic fractions to be able to solve some of these problems, and in a second, in the next video, you'll see that we'll also need it to be able to solve quadratic equations as well. So if any of that doesn't make sense, let me know, because if you do not understand what I've done